Let's determine the equation for each one of these. First of all, let's decide if it's growth or decay, if it's even exponential. So let's just kind of sniff through each of them and see what's happening. 16 turns into 8, which turns into 4. Okay, so this dude right here, f of x, he is halving. That's not spelled with an F. This is halving. I'm just making some notes. All right, 25, 30. Oh, we're adding 5. Let's add 5 again. Oh, man. Okay, so we add 5, we add 6, we add, now, whoa, 7.2. All right, okay, so we are increasing for sure. This is exponential growth, and if you want to just make that note, you can. This is exponential growth. I don't know what we are increasing by, but we are increasing, okay? 0.25, 0.5, 1, 2, 4, 8. Okay, this one's doubling. And then 243, 81, 27, 9. Now they're getting familiar. Okay, 81, 27, 9, 3, 1. Okay, this is exponential decay, and this is 1/3. I'm thirding. I'm having here, I'm thirding here, I'm doubling there. I don't know what I'm doing there. So let's just start writing some answers, and we're going to go one at a time. F of x equals, okay, well, where do we start? Oh, we started at 16. No, we didn't. We started at 8. Okay, that's your y-intercept. It's going to start at 8. So if you really want to get technical with these, this is the formula we're using. Y equals ab to the x. And I don't know the percent, but I can figure out the growth or decay factor. And it's always going to start with, well, 8 or 30 or 0.5 or 81. So let's actually do that. It's going to go one at a time. Let's not. Let's do all 4 of them at once. There we go. Oops. There we go. 0, that's your starting point. Okay, well, this one's halving every time. We're going to raise it to the x power. So as we go from one integer to the next, we are taking half of the number before it. Okay? For this one, I don't know. We are going to come back to this one. We'll figure it out in a minute. We're going to do the easy ones first. So this one's doubling, so we will double every time. So b is equal to 2. And this one, it's a third as we move forward. So this is 1/3 to the x power. All right, now we're back to the crazy one. So let's grab a calculator, and I want to show you something kind of cool. All right, let's go with the obvious, the one that was halving. I could do 8 divided by 16. So, all right, if I had the coordinate 0, 8, and I look at the coordinate that was before it, negative 116, one integer before it, I could do 8 divided by 16, and I'd get half, right? Okay, do it in your head, it's fine. I could also do this 2 divided by 4, and I'd get half. So whenever you have some consistency here, you can divide these to figure out what your percent of change is. It's beautiful. Okay, so again, same kind of situation could happen here. I could do, don't type this, I could do 4 divided by 2, and I'd get 2. Oh, that's why it's doubling. So now we can do the same thing here. We can do 30 divided by 25, and we'd get 1.2. So this is 1.2. Growth is 1.2. If you want to get technical, this is 20% growth. Whoa, 20%. Where'd you get that? Well, first of all, let me prove a point. Told you it was 1.2. Lights went out. 1.2. He's going to do them all, isn't he? 1.2. Yes, I am, and you're going to watch. Told you. Okay, so growth, and my growth factor is 1.2. But if you want to get technical, if you want to expand this into the other formula, and when I say other formula, I'm going back a little ways. I'm going back to this one. 1 plus 0.2, that 1 plus 0.2 would be, well, 1.2, which means the 0.2 is my rate, which means my rate is 20% growth. So even though I'm using this formula, I could talk about the other formula by saying that's 20% growth. All right. So that means that I'm going to have a 1.2 right here. And it makes sense because these numbers are increasing, so that must be greater than 1. These are increasing, that's greater than 1. These are decreasing, so these are less than 1, between 0 and 1.